All right, the next section is about solving inequalities. And the main thing you need to remember is whenever you multiply, okay, whenever you multiply or divide by a negative number, switch the inequality symbol. All right, I want to show you why this is true. Remember, in math, we only discover patterns. We discover math, we don't invent it. So let's take a look. Let me give you a true statement of an inequality. 5 is greater than 2. Agreed? Of course, 5 is greater than 2. Well, let's multiply both sides by -1, because of course what you do to one side, you must do to the other. And look what results. 5 is greater than -2. That is not true. That is a false statement. So in order to make it true, we must flip this guy around. So we have to turn around the inequality. Okay, and you could also do that with dividing. 2 is less than 6. Divide, let me do -2. Oh, let me do something like this. Ready? How about this? Even better. Well, I guess we're good. Actually, this is fine. -2 is less than 6. Let's multiply, or let's divide both sides by -1 to make that side positive. You will get 2 is less than -6. And that is not true. So you need to flip that inequality around. Anytime you multiply or divide by a negative number, you need to switch the inequality. If you get the problem wrong, check that first. Most likely that's where you messed up. It's kind of hard. Sometimes it's just kind of one of those triggers that you have to do by making mistakes enough. Making enough mistakes where it kind of triggers that whole thing happening. All right, so let's take a look. Okay, we're going to take a look at this inequality. And here we go. You operate an inequality just like as if this was an equal sign. Okay, unless this happens right here. Just act like it's an equal sign. It's totally fine. So we want to get v by itself. Okay, v is the variable. We need to get it by itself. We've got to get rid of the -3. What is the -3 doing? It's dividing. What's the opposite of division? Multiplication. Because this is written in a fraction form, I told you this will come up again and again. I kind of think it's easier sometimes to think of it as 3/1. For some, it will help you when we get into harder problems. Of course, it is just multiplying by -3. These would cancel, and you get v is greater than or equal to +18. And then you realize, oh, wait a minute. Oh, no. Actually, that's not true. Look what I just did. I multiplied by a negative number. So you must flip this inequality. Boom. Do you ever wonder why we don't put a positive on a positive number and yet we put a negative on a negative number? It's just the way we like it. It's called convention. All right, that's the answer to that. Moving on. Okay, for these, all you need to do for these is stick them into the equation and see if you get a true statement. That's the case for any time anybody wants to ask you if something is a solution. So -1 plus 7y is less than or equal to 27. This is where it's really, really, really nice to have a whiteboard because you could just do this. You just erase the y, plug in the -5, and you go times -5, and you get -1 plus -35. Is that less than or equal to 27? That's -36. Is -36 less than or equal to 27? Yes, it is. Okay, then you could just erase it again. Okay. On your papers, I would assume you would have all these problems. But I wanted to show you how fun it is just to erase it on a whiteboard if you have one. Times 9. -1 plus 63. Is that less than or equal to 27? You can already see that 63 is way bigger than 27. That's going to be 62. The answer is no. Okay. Next, plug in the next value. What's the next value? The next value is 0. So -1 plus 0. Is that less than or equal to 27? Yes, indeed. So all you're doing is evaluating these and seeing if they are true statements. All right, last one. Plug in a 4. 4. -1 plus 28. 27 is less than or equal to 27. Yeah, it's equal to. So yes, indeed. All right, last one. And most of these are all the same like this. They basically have a situation where you're going to end up multiplying or dividing by a negative number. So we subtract 1 here, and in this case it didn't. Oh, they're trying to trick you. That's what this one is. Look. See how the negative's over here? Okay. They're wondering whether or not you're going to be so happy to switch that inequality, you won't realize that you don't need to. Did you divide or multiply by a negative number? No. So don't switch the inequality. Don't do it. Okay? It says W is less than -6. We should probably talk about how to check it. You can basically check -6 or actually pick a number less than -6. Okay, something to the left of -6. Pick like -10. 2 times -10, I'll put it that way, plus 1, is that less than -11? -20 plus 1, is that less than -11? -20, -19 less than -11? Check. So obviously we can't check it for every single one, but it is a way to check and see if you are on the right path. All right, let me do one more like this. Let's say you have 3 minus 2x is greater than -4. Okay, subtract 3 from both sides. You get -2x is greater than -7. Divide by -2. Ooh, triggers. Hopefully that triggers that whole like, oops, I divided by a negative number. I need to switch it around. And you will get x is less than 7/2. Ah! Not allowed to do that. Not allowed to have that slanty fraction. 7/2. Boom. There you go.